All right, class, I got a request to make a video for this bone screw that we made in class this last Wednesday. So I'm going to go ahead and do a quick walkthrough on how to make this part. I'm going to go ahead and start from a new part. So I'm going to go File, New, Part, just like usual. This drawing unfortunately doesn't have units on it, but I do know this is millimeters. So I'm going to set this to millimeter gram second. And then I'm going to start by drawing the blank portion of the kind of the center of the screw without the threads and the head without the hole in it. So I'm going to go ahead and start on the front plane. I'm going to sketch, and then I'm going to draw just a rough outline of the screw. And I do want to try and set this so that way the bottom of the head of the screw is actually at the same point as the origin. And I can do that as two lines there or as one line. I did two lines just to make sure I got coincident with that point. And you can see I also have coincident with the vertical line here. So that's going to keep this line in this position and this line in this position. If you don't get those relations, you can't always just go through and add them by clicking on the line, clicking on the point, and then making those coincident. Or if you have two lines here, you click on the point, and then make those coincident, and that'll work out. Again, if you get things that are scaled off wrong, just go ahead and move them around until you've got something that's kind of an L shape like this. I've got a 10 millimeter length on the screw portion and a 1 millimeter thickness for the head of the screw. So I'm going to add the 10 millimeter first because I want to add the largest dimensions first generally. And it's going to scale everything else to match that. So this would be kind of close to where I want it to be, being just 1 inch or 1 millimeter long on this head here. So it's not too far off. The width of this head is 2.50. So I'm going to add the width here as 2.50, and I believe that's a radius, but it's an offset between the center and the edge in this view. And then the kind of the bottom of the threads, the minimal diameter of the screw, has a radius of 1 inch as well. So I'm going to add that 1 inch offset there. Now, if I want to, I can also go ahead and include the side geometry of this screw inside this sketch. And the way this is defined, that might be a little easier for me to do now, but I could do it later as well. I've got an arc here going to the bottom of this 1 inch offset, and I've got a 0.25 millimeter radius arc on the top. So I'm going to start with the 0.25 radius. I'm going to add this to this top edge. And then I'm going to try and use a 3-point arc to define this other arc here. So I'm going to change this from the center arc tool to the 3-point arc. And so I know it starts here, it comes to this edge, and it's got some radius here. And then I do want on this one to make it just like the drawing, I want this arc and this arc to be tangent. So I'm going to add that relation as well. And I want this point to be 1 millimeter from the base of the screw. So I'm going to specify that dimension as well. And that does fully define it. I have two little extra lines here, so I'm going to use the power trim tool to get rid of those. That did get rid of a dimension somewhere. So there's a horizontal relation that's not really necessary anymore. And we can move this around and try and figure out what am I missing. It looks like I probably need to keep this arc here set to be 90 degrees. So I'm just going to make this line and that point vertical to each other. And it also seems like this is turning into an offset dimension instead of a vertical dimension. So I'm just going to delete that and then remake it so that way it's always vertical with a distance of 2.5. And I lost my width here because that line disappeared. So I'm going to set that back to 1. Again, maybe not as easy as doing that after the fact or doing after it's been defined, but still work. I have a point here, which I'm not sure what that's for. That's probably left over from something I trimmed off. And so we're good here. With all that, I can go ahead and revolve this. So I'm going to go into Features, Revolve Boss Base. And then I'm going to select the center line of this, and that's going to revolve it around that point. I actually like to have in my sketches, I'm going to use Control-8 to go normal to view. A lot of times I'll draw a center line even if I don't need it to make it a little bit more obvious for anyone else who's using these parts, kind of what I'm doing. And then if you have the center line, you don't need to select it because it's going to use that by default. If you have more than one center line, then you would have to select that one or select the bottom edge. It doesn't matter how you do it, as long as you're able to get the geometry that you want. And it's also important to note that that sketch was fully defined and it's a closed cross section, so it makes it easy for me to turn that into a revolve. So that's kind of the base that I have for the part before I add the threads. To get the threads, I need the helix, which is the path of the extrude, as well as the cross-sectional profile, the actual tooth of the screw itself. So on here, what I'm going to do is I'm going to start on the end of the screw. I'm going to create a sketch, and then all I'm going to do is I'm going to convert the entities for that surface to make a circle on a new sketch that has the same diameter as the minor diameter of this cylindrical face right here. So there, I'm going to go ahead and use that circle, or really the sketch with the circle on it, to use the helix and spiral tool to kind of extrude that circle along a swept path. I like to use height and pitch because I know that this is 10 millimeters long, and I know I want a pitch of 1 millimeter because it says right here, pitch 1 millimeter. And so I'm going to take this and give it a height of 10 and a pitch of 1. I'm going to reverse so it goes along the path of this cylindrical face at the minor diameter of my screw. Now, it's also important for us to note that this has a starting angle, and so this is not starting off kind of aligned with any of my reference planes, which makes things a little bit more difficult in the future. So you know it's not really on the top plane or the front plane there. It's kind of in between those two. So I'm going to set this to 0. I almost always use a starting angle of 0 unless you want to start at some specific other value. I don't know why it defaults to something that's not 0. It doesn't necessarily make sense to me, but you know, do what you want. This one right here, the way this is designed, this will be a properly threaded screw, where when you turn the screw clockwise, it will go into the tissue or whatever it is you're screwing it into. If you want to have a reverse threaded through screw, you can do counterclockwise. Just keep in mind kind of which of those you're using. I think that that's pretty good. Again, you have other options for pitch and revolution if you want to define the helix a different way, but for this one, this combination probably is the easiest. So I'm going to accept that. Now I've got my path. I need a profile that is going to start at the end point of my screw, which is really why I wanted that start angle to be 0, because that makes the front plane and the end point of the helix kind of coincident. So if I can sketch on the front plane, I can come to this end point down here and I can draw the profile that I want for my tooth. I'm going to do this a little bit differently than I did in class, just to show you two new tools if you are watching this after having participated in class. I'm actually going to draw half of the thread and then mirror that about this center line. And hopefully it'll be obvious as to why I might want to do that after I get done. So I'm going to make the height of this 1. I'm going to draw the base of the thread, and then I'm going to use the Smart Dimension tool and click on the end of the line and the center line. And the advantage of doing that is I can use that for a kind of a radius or a center or a width based off where I place the mouse. So I want this screw to have a width of 0.9. It says it kind of right here in the drawing. But I'm going to mirror half of the thread geometry to the other side, so that way I get a symmetric thread, and I can add some more kind of complex feature to this. So click on that opposite side of the center line, give that a width of 0.9, so it's going to find our total width. Then I'm going to use the spline tool to draw the thread. I'm going to start this on the end point of this horizontal line and end it on the end point of the vertical line. Now that says that that's fully defined, but it's because I haven't moved any of the guide curves on here. Once I move the guide curves on this, you can see that it changes kind of the geometry of what I have going on here. And what you want to do is, if you actually want to fully define a spline, you need to define both the endpoints and the guide curves. So for this to be truly fully defined, I need to find the angle and the radius of each of these. So to get the radius, all I have to do is use the Smart Dimension tool and click on one of these guidelines, and it's going to give me a value here. That value is approximately the radius of the curvature at that point. So a larger radius means that it kind of extends that point out further, and a smaller one means it's kind of shorter. So I'm going to put in a value 2, and you can see how that makes that longer. And I'm going to put a different value down here. So this is 1, and and that makes it a little bit shorter. I'll change these a little bit so you can kind of play with them. You can see what it does. So you see if I make that value bigger, it extends that out, makes it a less dramatic curvature at the start, and then it has to compromise somewhere in the middle. So you can't go crazy and make this super long, and that super long is going to make it a really kind of weird looking curve. So I do want that to be 1. And then for the angles here, to get that, you click on the guide curve and then a reference line, and I can set this angle. So I want this angle to actually be pretty shallow. I'm going to use 20. And I want this one to be relatively steep. So I'm going to use 30 for that. That doesn't look very good. Let's use 60 for that. And then that looks okay on this end, but this is coming out a little too far, so maybe I'll change this to 1. And you can see how we change those parameters, and we get kind of different shapes for this. Maybe I want this to be a little bit narrower on the top, so I can change this around. Play with those values so you kind of understand how the spline works with different angles and radiuses. As you get to more and more control points, again, defining the splines fully can be very complicated, which is why we don't see those very often in your CSWA exams. But they're useful tools for us to be able to get kind of more organic curves. Once you have the spline defined the way you want it, the next thing I'm going to do is I'm going to exit the Smart Dimension tool. I'm going to mirror these 2 features about this center line. So here I have the Mirror Entities option. This is a sketch mirror. Most of the time, I don't really recommend that you use sketch mirrors and sketch patterns, because usually you're better off doing this on the feature level in the 3D geometry rather than on the 2D level. But for something like this, where I want a closed profile and it has a symmetric property, then I'm going to use that to make a sweep. I can't really mirror the sweep, right? If it was a boss extrude, I could mirror it and it would be fine. So there are situations where it's kind of helpful to be able to do that. So 2 options, very similar to the mirror properties and features. We have the things we want to mirror and the things we want to mirror about. So I want to mirror this line, and I want to mirror those about the center line. If you want to mirror them and not keep the original, you can uncheck this copy box, and then instead of making a copy of it and mirroring that, it will just mirror the original geometry. So it just moves it from the left to the right. So that's kind of a nice thing to know about as well. So I've got that, I'll accept that, and you have a new set of geometries that have a symmetric relation to the original one. You can delete these symmetric relations and then modify the mirrored geometry, which is another advantage of kind of the sketch mirror, is that you can use it to generate copies of objects and then modify those copies relatively easily. But hopefully that's helpful to you guys to look at. The thing to note is that we do have a closed contour here, because I did mirror this about the center line. The sketch was attached to that line on both places. So this does form one single closed contour that's all fully defined. So I'm good to move on to my features. So I'm going to use the swept boss base to turn this profile into an extruded profile. Because I had that sketch active, it's going to use that as the profile. The next thing I need to click is the path. And you can see that it has the little kind of hover over tooltip that tells us what that is, as well as the little icon that helps us understand what that's asking for. I'm going to click on the helix and spiral to select the path. If you're having a hard time clicking the helix and spiral from the workspace, you can always click it from the model tree here and the little drop down that comes up. And then once you have that, that looks good. We can go ahead and accept that sweep. And then the last thing that I want to, well, not the last thing, the second to last thing I want to do here is I want to add a tip to this, because obviously it's got, you know, a pointy spot. I don't want it to just be a weird kind of half a thread hanging off the end. So I'm going to go back to my front plane. I'm going to sketch on that. And I'm going to draw a trapezoid that's going to be a revolved cut to be able to take out most of the geometry here. I'm going to look for the center point of the end of this cylindrical face on my part. I'm going to try and get something close to 45 degrees here, come back across, come down, and then back in, again using a closed geometry. And then just to make it obvious for myself, I'm going to draw a center line that kind of comes through here. And it's important that that center line is coincident with the origin. It is right now because this is on the midpoint, but if you don't get that midpoint relation, you can always click on the center line here, hold Control, click the origin, make those coincident, and it's going to do the same thing. On mine, it over defines it because I already have that relation, but helping you guys out if you get a little stuck there. I want this angle to be 45 degrees Depending on what properties you're using on your spline, you may not be able to get this to work with 45 degrees. In class, I think I had to use 60 to get that to work. That's just an issue of trying to cut with this little kind of end point on the end, and then the geometry of the actual revolve itself. So don't worry too much if that gets stuck. It's just kind of a quirk of the features that we're working with here. I make this height 2. I should go all the way up to the edge of my spline. It looks a little too close for me. Let's go to 3 just to have a margin of error. And I'll make this distance down here 1. If I wanted to, I could also constrain this based off like the overall diameter of the height of my screw or something along that to make it more resilient to changes in sizes. But this will work for this for right now. Once I've got that defined, I'm going to go ahead and use the revolve cut. And then I'm going to accept that and just check and make sure that the geometry rebuilds okay. Because this is kind of a strange, sorry, I keep getting in the wrong spot. Because this is a kind of a strange shape here, there is an opportunity to kind of have little pieces of these that get cut off and have weird relative positions. So that revolve might not always work, but try not to worry too much if it doesn't work out the first time. There's ways you can go through and you can fix that by changing the starting angle or the geometry of the revolve and those kinds of things. I don't want to see this helix anymore, so I'm going to hide that one just so it doesn't show up inside my view. And the last thing I'm going to do is I'm going to add this 3mm hex head on the end of the bolt. So I'm going to sketch on the face, the part. I'm going to use the polygon tool to make a 6-sided polygon. I'm just going to align that horizontally to start off with. Give it a width of 3mm. And then this is enough to have this work, but if you do want it to be fully defined, you can just define any one of these points to be horizontal with the origin, and that'll prevent the polygon from kind of rotating in place. Not going to really change the performance of the part at all, but it's nice to make sure that our parts are fully defined. I'm going to extrude cut that to a depth of 0.5mm. And then I've got the finished part. So hopefully that was helpful for all of you that were following along. And we can see that this is a nice little screw. And if I want to look at the section view, I can confirm that this looks just like I have it in the drawing here. You know, it looks very similar. So we should be good to go. If you have any questions, feel free to reach out. If not, I'll see you all again in class.